All right, this is lesson 5 on negative exponents. So we're going to prove what a negative exponent has to equal. So let's say we had 3 to the 5th over 3 to the 5th. Okay. Now we know that this equals 1. We can know this by a couple ways. We can either do the quotient rule, which means we do 5 minus 5. So this is just 3 to the 0. And we know that that equals 1. Or we can look at the fact that we have the same thing on top of the same thing, which means, of course, it equals 1. So 3 to the 5th over 3 to the 5th equals 1. Now, what if we had 3 to the 5th times 3 to the negative 5th? Well, here we can do the product rule that says we're going to add 5 plus negative 5, which we also know means 0. And 3 to the 0 equals 1. So here we see two versions of pretty much the same thing. Okay? And take a look at what's changed from this one to this one. Both of them have a 3 to the 5th, so that's the same, but the part that's different is what's important. This part right here and this part right here. So because only we got one thing changed, yet we got the same result, we know that these two things are equal to each other. So that means that 1 over 3 to the 5th, which is what this is because it's on the bottom, is equal to 3 to a negative 5th. Okay? So you take notice that if I have 3 to a negative 5th, it can equal the same thing, but just on the bottom, but now it's positive exponents. Okay? And that is essentially what today's lesson is about, that you can take negative exponents that are on the top and move them to the bottom to make them positive, and actually vice versa, which I will show you. So let's look at a couple of examples of this. I'll stop there for now. So 4 to a negative 2, an equivalent of this, or if I just wanted to make sure that I changed the exponent to be positive, I can take this, because it's a whole number, so technically it's on the top, and move it to the bottom. And that's the same thing. For the next one, doing the same thing, it's technically on the top because it's a whole number, 1 over 16 to the 4th. And see that the exponent becomes positive. Same thing for here, so you can see it doesn't really matter what our base is, the property still stands. 1 over negative 3, keep that parentheses, to a positive 3. Okay, so these are all the same thing, they're all equivalent. And this is a really nice way, and you can always go backwards too. So if I gave you 4 to the 2nd under 1, you can move it to the top by making it negative. Let's look at some more examples. All right, and this is to show you that it works with whatever our base is. Okay, so let's say we had a decimal as a base. Well, it's whole, so and it's on top, so we just put it underneath 1. Oh, oops, I made that mistake. This would be positive 2. Okay, same thing here. Put it under 1, and it becomes positive. Now you could put a 1 here, or you could leave it alone. I'll just put a 1 here, but you can leave it as just 1 over x. Same thing. Now here, the exponent right here is not negative, but because we know the distributive property, let's see what happens. So we put the 3 on the x to the 3rd. We put the 3 on the y, which means we'd have to do -2 times 3. So that's still x to the third. That becomes y to a -6. Now, the general rule is that you don't leave exponents negative. So we need to move anything that is negative. So the x can stay where it is, but we need to move the y. So the x can stay on the top, but the y we move to the bottom, and it becomes positive. So our answer we would leave like that. Okay? But all these are technically equal. They're all equivalent. Okay? Let's take a look at what happens with fractions, because we love fractions. Okay, let's take a look at these two. So remember, you only move what is actually negative. So the 1 is not negative, so we don't need to move it, but most of the time it won't really change anything anyways. We're going to change, though, this 2 because it's to a -2. So because it's on the bottom, I'm going to move it to the top. So this becomes 2 to a 2, and if it really helps you, you can think about, oh, I'm putting it to the top. Or if you want to, you can just simplify it a little bit further and just go to squared. Okay, and that is the more simpler way of thinking about it, and this is what they'd expect you to do in high school, is to leave it like that. All right, down here, the 3, we don't want to do anything with the 3, so there's definitely 3 on the top. Then this 4 we need to move because it has a negative exponents. So we'll move it to the top, and it becomes positive. Now these are not the same base, so we can't combine them. Okay? Now we could leave it like this, or because we don't really need to say that it's over 1 because every number is over 1, we can change it to be like this, and that'll be our answer. Okay. Now let's look at a different case. Let's say we had an entire fraction in parentheses to a negative power. There's 2 different ways to think about this. One way to think about this is that each of these things we can essentially distribute that -2. So we put this -2 on the 4, so it's 4 to the -2. Put the -2 on the 5, so it's 5 to a -2. And then they both need to move to become positive. So this 5 needs to go to the top to become positive, 5 to the squared, and this 4 needs to move to the bottom to become positive, 4 squared. And we could leave it like that. Okay. Another way to do it, and I'll rewrite it so it's nice and clean again. Another way to do this is to think, oh, I'm flipping everything. Okay? So you just take it, flip the fraction that's inside, and change this to become positive. And I know these look different, but they're actually the same thing. This just has that 2 distributed. This is the same. So either one you come up with, they're the same thing. Let's look at some more examples of that. All right, again, the long way would be to distribute the -3 onto both of them. So you have a 7 to a -3 over 8 to a -3. And then the 7 needs to go to the bottom, and the 8 needs to go to the top. Okay? So you can do it that way, or we can just do the flip method. 7 over 8 to a -3rd. Take whatever's inside, flip it, so the 8 goes over the 7, and then you just change that exponent to be positive. Okay, so either way is perfectly fine. This top way is a little bit longer, but it's the same thing. Okay. All right. So the general rule for negative exponents Okay, so our general rule for negative exponents is that you can get rid of negative exponents by moving it either from the top to the bottom or from the bottom to the top, and it becomes positive. And you can actually go the other way too. If you really want to make something negative, you can move it from the top to the bottom and vice versa as well. Now, the general rule though for just doing math is that you always leave your answer in positive exponents. So from now on, when you're doing this, I'm going to expect that all of your answers are positive. Otherwise, I will mark them incorrect. Unless, of course, the instructions say to leave it as negative or make something equivalent regardless and all of that. Okay? So in general, if it doesn't say something about it, you leave your answers with positive exponents. Okay? So one last thing before this video is out, I just want to show you going the other way. So making positive things negative. Not that you'll use this much in this class, but it's just good to know that you can go the other way. So let's say I had x to the 5th, 1 over 3 to the 2nd, and let's think of something else. Y squared over z cubed. Right? So maybe just for fun, I want to change all these to have negative exponents. It's the same principle. You just move them from where they are to the other way. So this one's on the top because it's a whole number. So we'll put it under 1, and the sign changes. Okay? Same thing here. It's on the bottom. So if I move it to the top, the sign changes, and we can leave it like this, or we can write it like this. Okay? On the bottom, everything's essentially just going to switch. So the y is going to go to the bottom, and the sign's going to change, and the z is going to go to the top, and the sign's going to change. Okay? So you can go vice versa. You can go back and forth. Okay? And that's